We are standing at the edge of everything we know. Behind us, the familiar blue marble of Earth spins in its comfortable orbit, a mote of dust suspended in a sunbeam, as Carl Sagan once remarked with his characteristic blend of poetry and precision. Before us stretches the observable universe, a sphere of spacetime extending roughly 46.5 billion light-years in every direction, containing somewhere between 200 billion and 2 trillion galaxies. Each one a cosmic city of stars. Each one a universe unto itself. What would it mean to fly through them all? The question seems absurd at first, doesn't it? Like asking what it would be like to count every grain of sand on every beach, in every coastal region, on every continent, throughout all of Earth's history. The task defeats imagination before imagination can even properly form. Yet here we are, creatures who evolved to pick berries and avoid predators on the African savanna, daring to dream of crossing the entire observable cosmos, of visiting every single one of its galactic archipelagos scattered across the dark sea of space. This is humanity's particular madness. Our beautiful, terrible gift. We are the species that looks at the impossible and says, "Let me tell you what it would be like." So let us embark on this journey together, you and I. Let us fly through every galaxy in our observable universe. Not in body, that would take longer than the universe has left to live. But in mind, in imagination, in that peculiar space where mathematics meets metaphor and science becomes something very much like prayer. Our journey begins not with a leap, but with a single step, if stepping into a spacecraft capable of near light-speed travel can be called simple. The engineering required to build such a vessel belongs more to the realm of theology than technology at our current level of development. We're talking about a machine that would need to shield its occupants from radiation that would turn human flesh to vapor in nanoseconds, that would need to carry fuel enough to accelerate to velocities that make a mockery of Einstein's cosmic speed limit, that would need to last for epochs measured not in human generations but in geological eras. But let's assume, for the sake of this grand thought experiment, that we've solved these trivial problems. Let's imagine we have a ship. Let's call it the Endurance, the Prometheus, the Icarus, no, two on the nose. Let's call it the Wanderer. Yes. The Wanderer. A name without pretension, without hubris. Just a simple statement of intent. The Wanderer sits on its launch pad, if launch pad is even the right term for a structure that might need to be built in orbit, or at a Lagrange point, or perhaps on the far side of the moon where Earth's gravity well won't clutch at it like a jealous parent unwilling to let go of a child. It gleams in the unfiltered sunlight, though gleams might not be the right word either. Perhaps it doesn't shine at all. Perhaps it's matte black, designed to absorb every photon, to become as close to invisible as the laws of thermodynamics allow. Inside, the crew makes their preparations. Or perhaps there is no crew. Perhaps this is a journey for artificial intelligence alone, for digital consciousness uploaded into quantum processors, freed from the tyranny of biological needs. After all, flesh is weak. Flesh needs food, water, air, gravity, protection from cold and heat and radiation. Flesh grows old and dies, usually in that order, though cancer sometimes reverses the process. Flesh falls in love and misses home and goes quietly mad in the vast silence of space. But whether crewed by humans, post-humans, or pure mathematics given purpose, the Wanderer prepares to depart. Systems check out. Fusion reactors hum to life. The Alcubierre drive, or whatever space warping, reality-bending propulsion system we've managed to invent, begins to fold spacetime like an origami artist working with the fabric of existence itself. And then, without ceremony, without fanfare, without anyone to wave goodbye, we go. The first galaxy we fly through is our own. The Milky Way. Home. A barred spiral galaxy measuring roughly 100,000 light-years in diameter. Containing somewhere between 100 billion and 400 billion stars, depending on which astronomer you ask and how much they've had to drink. It's a middle-aged galaxy, neither young and violent nor old and quiescent, with spiral arms that trail through space like the wake of a cosmic ship. We've lived our entire history here, in this one galaxy, on one planet orbiting one star in the Orion Arm, a minor spur between two major spiral structures. Every human who ever lived, every civilization that rose and fell, every war fought and peace declared, every discovery made and forgotten, all of it happened in this one tiny corner of this one galaxy. But now we're leaving. The sensation, if there were sensation, would be like watching your childhood home recede in a rearview mirror for the last time, knowing you'll never return. Except the home in question is 100,000 light-years across and contains hundreds of billions of suns. We pass through regions where new stars are being born in great stellar nurseries, clouds of gas and dust collapsing under their own gravity, igniting nuclear fusion in their cores, beginning their long slow burn that will last for millions or billions of years. We pass through regions where old stars are dying, some quietly fading to white dwarfs, others exploding as supernovae, briefly outshining entire galaxies before collapsing into neutron stars or black holes. The diversity is staggering. There are red giants so large that if you placed them where our sun sits, their surfaces would extend past the orbit of Mars. There are white dwarfs so dense that a teaspoon of their matter would weigh as much as an elephant. There are neutron stars spinning hundreds of times per second, their magnetic fields so intense they could erase your credit cards from 1,000 kilometers away, if credit cards were remotely your biggest concern in that scenario. There are black holes, of course, those ultimate enigmas, regions where gravity has won its final victory and pulled spacetime into a knot so tight that nothing, not even light itself, can escape. And planets. Oh, the planets. Rocky worlds and gas giants, ice planets and lava worlds, rogue planets drifting through interstellar space without any star to call their own. Some of them might harbor life. Probably do, if the mathematics of probability have any say in the matter. Microbes in subsurface oceans. Fungal forests beneath ice sheets. Perhaps even complex ecosystems, thinking creatures, civilizations that have risen to their own enlightenment or destroyed themselves in nuclear fire or ecological collapse. We don't stop to check. We can't. That's not the mission. The mission is to fly through every galaxy, not to explore every world. If we stopped at every potentially interesting planet in just our own galaxy, we'd never leave, never complete the journey. So we fly on, through the heart of the Milky Way, past the supermassive black hole at its center, Sagittarius A-, a beast containing 4 million times the mass of our Sun, mercifully dormant for now but once an active quasar that blazed like a cosmic lighthouse. We emerge from the far side of our galaxy, and for a moment, if moments have any meaning at the speeds we're traveling, we look back. The Milky Way stretches across the sky like a river of light, and somewhere in there, too small to see even if we had telescopes powerful enough, is Earth. Is the cradle. The place where it all began. Then we turn away and face the dark. The space between galaxies is not truly empty, though it's close enough to make no practical difference. A few stray hydrogen atoms per cubic meter. Some dark matter, that mysterious substance that makes up most of the mass of the universe but refuses to interact with light or ordinary matter except through gravity. Cosmic radiation from the Big Bang itself, cooled now to just 2.7 degrees above absolute zero, whispers through the void. We traverse this emptiness toward the Andromeda Galaxy, our nearest large neighbor. It's a journey of 2.5 million light-years, which sounds like forever but is actually just next door in cosmic terms. Andromeda is larger than the Milky Way, containing perhaps 1 trillion stars. And it's heading toward us at about 110 kilometers per second. In about 4 billion years, our two galaxies will collide, merge, form something new. But that's future tense, and we're concerned with the present. As we approach Andromeda, it grows from a fuzzy smudge into a magnificent spiral, its arms more tightly wound than the Milky Way's, its core blazing with billions of older yellow stars. We dive into it like a swimmer entering water, and the sensation, again, if there were sensation, would be of plunging into light itself. So many stars. So much nuclear fire burning in the dark. Andromeda has its own retinue of dwarf galaxies, small satellites that orbit the main body like moons around a planet. We make note of them, M32, M110, and others. Each is a galaxy in its own right, containing millions or billions of stars, but they're dwarfed, hence the name, by Andromeda's grandeur. We'll need to visit these too. Every galaxy. That was the deal, wasn't it? Every single one. The Triangulum Galaxy comes next, also known as M33. It's smaller than both the Milky Way and Andromeda, containing perhaps 40 billion stars, but it's beautiful in its own right, a face-on spiral that looks like a cosmic pinwheel. We fly through it, cataloging structures, noting details that would take human astronomers centuries to study, but which flash by in what we might call an instant if time hadn't become a somewhat negotiable concept at the speeds we're traveling. These three large galaxies, the Milky Way, Andromeda, and Triangulum, form the core of what astronomers call the local group. But the local group contains more than 80 galaxies in total, most of them dwarfs. There's the Large Magellanic Cloud and the Small Magellanic Cloud, satellites of the Milky Way visible to the naked eye from Earth's southern hemisphere. There's the Sagittarius Dwarf, actually in the process of being torn apart and consumed by the Milky Way. Galactic cannibalism is more common than you'd think. There are dozens of other dwarfs with prosaic names like Draco Dwarf and Ursa Minor Dwarf and Sculptor Dwarf, each one a collection of stars bound together by gravity, each one unique. We visit them all. One by one. And with each galaxy we traverse, a strange feeling begins to develop. Not boredom, how could anyone be bored witnessing such magnificence? But perhaps something like the feeling you get after visiting your 50th cathedral in a European tour. Awe fatigue. The diminishing returns of wonder. Each galaxy is a miracle, yes, but when you've seen dozens of miracles, the word starts to lose its meaning. This is only the local group. We haven't even left our cosmic neighborhood yet. And already we can feel the scale of the task ahead settling onto our shoulders like a weight that might crush us. But we push on. What else can we do? Beyond the local group lies the larger structure of which we're a part, the Virgo supercluster. This is a collection of roughly 100 galaxy groups and clusters, containing about 47,000 galaxies, all gravitationally bound together in a region of space about 110 million light-years in diameter. At its heart sits the Virgo cluster itself, a massive congregation of galaxies dominated by the giant elliptical M87. M87 is a monster. An elliptical galaxy containing several trillion stars. The estimates vary wildly because counting stars in elliptical galaxies is like trying to count bees in a swarm. But more impressively, at its center lurks one of the largest black holes ever discovered, a supermassive beast containing 6.5 billion times the mass of our Sun. This is the black hole that the Event Horizon Telescope famously imaged in 2019, giving humanity its first direct visual evidence of these spacetime singularities. From its poles shoot jets of matter and energy that extend for 5,000 light-years, particle beams moving at nearly the speed of light, powered by the gravitational energy of matter falling into the black hole's maw. We approach M87 with something like respect. Fear, maybe. This galaxy has been actively feeding its central black hole, and even at our distance we can detect the radiation, the high-energy photons, the cosmic rays being accelerated to impossible energies. If we got too close, those jets could sterilize our ship, scramble every circuit, ionize every atom. But we thread the needle, passing through the outer regions of M87, witnessing this galactic behemoth from the inside. And then we move on to the next galaxy in the Virgo cluster. And the next. And the next. Here's where the mathematics of our journey begin to feel genuinely crushing. The Virgo cluster alone contains between 1,300 and 2,000 galaxies, depending on how you count. If we spent just one day, one single day, in each galaxy, it would take us between 3.5 and 5.5 years to visit them all. But one day is absurd. Even moving at relativistic speeds, flying through a galaxy takes time. The Milky Way is 100,000 light-years across. Even if we're moving at 99.999% the speed of light, even with time dilation turning decades into months from our perspective, we're still looking at significant time investments for each galaxy. But let's not dwell on the math too much. That way lies madness, or at least despair. Instead, let's focus on the variety, the sheer overwhelming diversity of galactic forms we encounter. There are spiral galaxies like our own, with their elegant arms of stars and dust. But spirals come in different flavors: grand design spirals with two clear arms, multi-armed spirals that look like cosmic flowers, barred spirals where the arms connect to a central bar structure rather than directly to the core. There are lenticular galaxies, intermediate forms between spirals and ellipticals, with a disk but no spiral structure. There are elliptical galaxies, ranging from nearly spherical giant ellipticals to elongated cigar-shaped forms. There are irregular galaxies that defy easy classification, their shapes determined by gravitational interactions with neighbors, by mergers and near collisions, by the chaotic processes that govern galactic evolution. Each galaxy tells a story. We pass through galaxies in the process of merging, their structures distorted by tidal forces, long streams of stars pulled from one galaxy to another by gravity's inexorable grip. We pass through quiescent galaxies where star formation has nearly ceased, their populations dominated by old red stars, their fuel for making new suns depleted or locked up in forms that can't collapse to form stellar nurseries. We pass through starburst galaxies experiencing episodes of furious star formation, their interiors blazing with the light of millions of young, hot blue stars that will burn themselves out in just a few million years. The Virgo supercluster sprawls across space, and we fly through it in a path that would look, if you could see it from outside, like the wandering of a bee from flower to flower, or perhaps more accurately, like a three-dimensional spirograph drawing, a pattern of loops and curves dictated by the distribution of galaxies in space. Time becomes strange. From our perspective, with relativistic effects compressing the experience, years might pass while we traverse a particularly large supercluster. But back on Earth, if Earth still exists, if humanity hasn't destroyed itself or evolved into something unrecognizable, millions of years roll by. Continents drift. Ice ages come and go. Species evolve and go extinct. Mountains rise and erode. The entire story of human civilization from the agricultural revolution to the present would be a brief moment in deep time, and we're talking about timescales vastly longer than that. Do we think about this? Do we mourn? Or have we accepted that this journey is a one-way trip not just in space but in time, that everyone we knew, everyone we loved, every enemy we despised, has turned to dust while we cavorted among the galaxies? Perhaps that's why we keep moving. What else is there to do? In 2014, astronomers realized that the Virgo supercluster is actually just one component of an even larger structure they named Laniakea, Hawaiian for immeasurable heaven. Laniakea is a galactic supercluster containing roughly 100,000 galaxies spanning 520 million light-years. It's not held together by gravity alone. At these scales, dark energy's repulsive effect is starting to overcome gravitational attraction, but rather by the pattern of galaxy motions, all flowing toward the region's center of gravitational mass. We're now operating at scales that defy human intuition. 520 million light-years. Light itself, moving at 300,000 kilometers per second, would take 520 million years to cross this structure. And we need to visit every galaxy within it. Let's pause here for a moment of philosophical reflection. What does it mean to visit a galaxy anyway? To pass through it? To observe it from the outside? To study it in detail? We've been using "fly through" as our operational definition, but the more we think about it, the fuzzier the concept becomes. If we fly through the outskirts of a galaxy, does that count? What about dwarf galaxies that are so small they're barely distinguishable from globular clusters? What about galaxies in the process of merging? Do we count them as one galaxy or two? What about the galaxies we can see but that no longer exist, their light having traveled to us for millions of years while the galaxies themselves evolved into something different or were consumed by larger neighbors? These questions might seem like pedantic quibbling, but they point to something deeper: the difficulty of applying simple concepts to complex realities. Galaxies aren't discrete, countable objects like apples in a basket. They're fuzzy, evolving, interacting systems with poorly defined boundaries. The space between galaxies contains stray stars, gas clouds, dark matter halos that extend far beyond the visible structures. Where does one galaxy end and another begin? Where does a galaxy end and intergalactic space start? We decide, somewhat arbitrarily, that flying through the central region where most of the stars are concentrated counts as visiting a galaxy. It's not a perfect definition, but it's workable. And so we continue. Laniakea contains several major superclusters within it. We've already covered the Virgo supercluster. Now we move on to the others: the Hydra Centaurus supercluster, the Pavo Indus supercluster, and the Southern supercluster. Each contains thousands of galaxies. Each spans tens of millions of light-years. The Hydra Centaurus supercluster is particularly interesting because at its heart sits something called the Great Attractor, a gravitational anomaly that's pulling not just individual galaxies but entire galaxy clusters toward it. The great attractor itself seems to be a concentration of mass, possibly dominated by the Norma cluster, a cluster of galaxies that lies in the zone of avoidance, the region of the sky obscured by the Milky Way's disk, making it difficult to study from Earth. But we're not on Earth anymore. We can approach it from any angle we like, and when we do, we find, well, more galaxies. A concentration of them, certainly, but nothing that seems to justify the dramatic name. The great attractor is great primarily because of its gravitational influence, not because of any visual splendor. Still, we catalog it. We fly through the Norma cluster, through the thousands of galaxies that make up this region of high density. And then we move on. The pattern is becoming familiar now. Jump to a new region of space. Identify the nearest galaxy. Fly through it. Move to the next. Repeat. Again and again and again. Like a cosmic version of a tedious bureaucratic task, stamping forms, filing papers, except instead of forms and papers it's galaxies and galaxy clusters. But here's the thing, each galaxy, when you examine it closely, remains unique. This galaxy has an active quasar at its center. That one is undergoing a starburst triggered by a collision with a neighbor. This spiral has unusually prominent dust lanes. That elliptical is surrounded by an extended halo of globular clusters. Every galaxy is a world unto itself, an ecosystem of billions or trillions of stars, each potentially surrounded by planets, some of those planets potentially harboring life. The sheer magnitude of possibility is staggering. In each galaxy we pass through, there might be millions of worlds with life, thousands of civilizations, hundreds of spacefaring species. Or there might be none. The universe might be empty except for us and the microbial life that probably exists on countless worlds but never evolves beyond single-celled organisms. We can't stop to check. That's not the mission. The mission is to fly through every galaxy, not to answer the question of whether we're alone in the universe. But the question haunts us anyway. In galaxy after galaxy, we see planetary systems, we detect biosignatures in some of the atmospheres, we even occasionally spot what might be evidence of technology, artificial structures, energy patterns that don't match natural phenomena. But we don't slow down. We can't. The journey is too long already. Later, we tell ourselves. We'll send the data back. Someone else can follow up. Someone else can make contact, establish communication, join the galactic community if one exists. Our job is simpler, just pass through. Just visit. Just bear witness. It's a lonely thought. As we venture beyond Laniakea, the large-scale structure of the universe becomes more apparent. Galaxies aren't distributed randomly through space. Instead, they're arranged in a vast cosmic web, a three-dimensional network of filaments and sheets surrounding enormous voids. The filaments are where the galaxies are, long, thin structures sometimes stretching for hundreds of millions of light-years, containing thousands upon thousands of galaxies strung out like lights on a cosmic string. The voids are where the galaxies aren't, vast empty regions, sometimes 300 to 500 million light-years across, containing very few galaxies and lots of dark matter and dark energy but not much ordinary matter at all. This structure emerged from tiny quantum fluctuations in the early universe, microscopic variations in density that existed moments after the Big Bang, that got amplified by cosmic inflation, that grew over billions of years as gravity pulled matter together into ever larger structures. What started as variations of one part in 100,000 grew into the cosmic web we see today, with its filaments and nodes and voids. We follow the filaments when we can, that's where the galaxies are, after all. But sometimes our path takes us through the voids, and that's when the true scale of cosmic emptiness becomes apparent. In a void, the nearest galaxy might be tens or even hundreds of millions of light-years away. Space becomes so empty that it's almost abstract, a purely geometric concept rather than a physical place. If the observable universe were compressed down to the size of Earth, a void would be like the Pacific Ocean, vast, mostly featureless, with only occasional islands to break the monotony. But the voids aren't completely empty. They contain dark matter, that mysterious substance that outweighs ordinary matter by a factor of 5 but only interacts through gravity. They contain dark energy, that even more mysterious entity that's causing the universe's expansion to accelerate. And they contain stray atoms, the occasional hydrogen molecule, photons of various wavelengths traveling from distant sources. Flying through a void is like sensory deprivation. In the filaments and clusters, we're constantly bombarded with light from billions of stars, with radiation from active galactic nuclei, with gravitational influences from massive structures. In the voids, all that fades away. The nearest galaxy becomes a distant smudge, and the vastness of space presses in with an almost physical weight. Some of the voids have names. The Boötes void, discovered in 1981, spans 330 million light-years and contains only about 60 galaxies where you'd expect to find 2,000. The supervoid in Eridanus, possibly responsible for the cold spot in the cosmic microwave background, spans 1.8 billion light-years. The giant void in Canes Venatici, the Capricornus void, the Microscopium void, each one a region of space so empty it strains comprehension. We traverse them all. And in each void, we find the few galaxies that do exist there, lonely island universes in vast seas of emptiness. These void galaxies tend to be different from galaxies in clusters. They're often more actively forming stars, less disturbed by gravitational interactions with neighbors, bluer in color due to younger stellar populations. They're laboratories for studying galaxy evolution in isolation, and we catalog them as we pass through. The cosmic web leads us inexorably outward, away from our starting point, away from Laniakea and the local group and the Milky Way. We're heading toward more distant superclusters now, the Shapley supercluster, one of the largest concentrations of galaxies in our corner of the universe, the Hercules supercluster, the Coma supercluster, centered on the famous Coma cluster where Fritz Zwicky first discovered evidence for dark matter in the 1930s. Each supercluster contains thousands or tens of thousands of galaxies. Each represents years or decades or centuries of travel time, even at relativistic speeds. Each is a universe of possibilities, of worlds and suns and the stories that might be unfolding on planets we'll never visit. The numbers are starting to numb us. When you've flown through 10,000 galaxies, the 10,001st doesn't feel particularly special. When you've witnessed 100,000 supernovae, the next one is just another stellar explosion. When you've seen 1 billion planetary systems, you stop imagining what might live there and just record the data and move on. This is the curse of grand ambitions, they grind down wonder into routine. The extraordinary becomes ordinary through sheer repetition. We're living through the most magnificent journey in history, witnessing sights that would have driven ancient humans to their knees in worship, and we're starting to feel bored. Exhausted. Eager for it to be over. But we're not even close to finished. We've covered perhaps a few % of the observable universe. Perhaps less. The mathematics are daunting enough that we've stopped calculating exactly where we are in the journey. We just keep moving, galaxy to galaxy, cluster to cluster, one more and then one more and then one more. The Sloan Great Wall, a structure at the edge of comprehension. Eventually we reach the Sloan Great Wall, a vast galactic filament measuring 1.37 billion light-years in length. It's one of the largest known structures in the universe, a concentration of galaxies forming a wall-like structure that stretches across our view like a cosmic fence. The Sloan Great Wall is named after the Sloan Digital Sky Survey, the astronomical survey that discovered it, and it contains tens of thousands of galaxies arranged along a vast filament. To call it a wall is somewhat misleading. It's not a solid structure but rather a region of higher galaxy density, shaped by the gravitational dynamics of cosmic evolution. But from certain perspectives, it does look like a wall, a barrier dividing one region of the universe from another. We fly along it, through it, visiting galaxy after galaxy after galaxy. The experience is surreal. Galaxies that would individually be considered cosmic treasures, worthy of detailed study and decades of observation, flash by like fence posts seen from a fast-moving car. Spiral galaxies, elliptical galaxies, irregular galaxies, they blur together in our perception, becoming not individual objects but samples of types, data points in a vast statistical distribution. Here's a spiral galaxy with particularly well-defined arms. Check. Move on. Here's an elliptical galaxy in the process of cannibalizing a smaller neighbor. Check. Move on. Here's a starburst galaxy with an active galactic nucleus. Check. Move on. The routine is mind-numbing, but it's also the only way to accomplish the mission. If we spent even an hour studying each galaxy in detail, the journey would take longer than the current age of the universe. We have to keep moving, keep the pace up, trust that the act of passing through is sufficient. But what are we accomplishing, really? What's the point of this journey? To say we've done it? To satisfy some abstract notion of completeness? To fulfill a mission whose purpose we've perhaps forgotten, if there ever was one? These are dangerous thoughts. The kind of thoughts that lead to mission failure, to turning back, to giving up. We push them aside and focus on the task. Next galaxy. Then the next. Then the next. The Sloan Great Wall eventually gives way to other structures, the Boss Great Wall, even larger at 1.5 billion light-years across, the Hercules Corona Borealis Great Wall. A structure so large that some astronomers question whether it can even exist within the current cosmological models, stretching over 10 billion light-years and possibly violating the cosmological principle that states the universe should be roughly homogeneous at the largest scales. We traverse them all. Or rather, we begin to traverse them, understanding that structures at these scales will take hundreds of millions of years to cross, even at relativistic speeds. Time continues to dilate, continues to compress from our perspective, but the objective time, the time measured by any observer not traveling at near light speed, continues to accumulate. If Earth still exists, if the sun hasn't expanded into a red giant and swallowed it, if humanity hasn't gone extinct or evolved into digital consciousness or spread across the galaxy or destroyed itself in nuclear war or ecological collapse, then Earth is now millions or billions of years older than when we left. The continents have rearranged themselves. The face of the planet is unrecognizable. If there are still humans, they've evolved so much that they might as well be a different species. Our own DNA, assuming we still have DNA and haven't been uploaded into computer systems or reconstituted as pure energy or transformed into something unimaginable, would seem archaic, primitive. We are fossils from a different age, anachronisms persisting only because we're traveling fast enough that time has nearly stopped for us. We're like the protagonist in a science fiction story who goes on a long journey and returns to find everyone they knew dead and the world changed beyond recognition, except we're never returning. This journey is a one-way trip, not just through space but through time. We left everything behind when we departed, and the universe has continued without us. The loneliness of this realization is crushing. But there's no time to dwell on it. There are more galaxies to visit. Always more galaxies. The quasar era, looking back in time. As we travel farther from our origin point, something interesting happens. We start seeing the universe as it was in the past. This is an inevitable consequence of the finite speed of light. When we look at a galaxy 100 million light-years away, we're seeing it as it was 100 million years ago, when the light currently reaching us first left its surface. When we look at a galaxy 1 billion light-years away, we see it as it was 1 billion years ago. And as we fly farther and farther, visiting galaxies more and more distant from our starting point, we start to notice that the galaxies look different. Younger. More chaotic. The smooth elliptical galaxies and well-ordered spirals become less common, replaced by irregular forms, by proto-galaxies still in the process of formation, by galaxies actively merging and colliding and tearing each other apart. And we start to see quasars. Lots and lots of quasars. A quasar, short for quasi-stellar radio source, is an active galactic nucleus powered by a supermassive black hole actively accreting matter. The infalling material forms an accretion disk, a swirling maelstrom of superheated gas and dust spiraling toward the black hole's event horizon, and this disk can outshine the entire host galaxy, making quasars some of the brightest objects in the universe. From Earth, quasars look like points of light, hence quasi-stellar, but up close, they're revealed as galaxies with incredibly violent cores. Quasars were much more common in the early universe than they are today. Most supermassive black holes in modern galaxies are quiescent, not actively feeding. But in the universe's youth, when galaxies were still forming and colliding frequently, when there was more available gas to fuel the black holes, quasars were everywhere. As we travel to more distant, and thus earlier, parts of the universe, we're essentially traveling backward in cosmic time. We're witnessing the universe as it was billions of years ago. And that universe looks different. Wilder. More energetic. More dangerous. Flying through a quasar galaxy is an experience unlike flying through a modern, quiet galaxy. The radiation levels are intense. The core blazes with energy that would sterilize any planetary systems for thousands of light-years around. Jets of matter moving at relativistic speeds shoot from the poles of the supermassive black hole, creating structures light-years long. The entire galaxy seems to be in the grip of a cosmic fever, burning with an intensity that can't last, that will eventually die down as the black hole runs out of nearby material to consume. We pass through galaxy after galaxy like this. Active galactic nuclei. Quasars. Blazers, quasars with jets pointed directly at us, or rather, in our direction, since we're seeing them billions of years in the past. Seyfert galaxies. Radio galaxies. Every category of active galaxy, every type of nuclear activity. And between these violent systems, we see galaxy collisions in progress. Mergers where two spiral galaxies are tearing each other apart, their stars redistributed, their gas clouds shocked into forming new stars at prodigious rates. These are the starbursts, galaxies forming stars at rates hundreds of times faster than the Milky Way's sedate pace. These newborn stars are hot and blue, and they'll burn themselves out in just a few million years, but while they last, they light up their host galaxies like cosmic fireworks. This is the universe's adolescence. Its wild youth. Before it settled down into the more orderly, mature cosmos we see in our local neighborhood. It's chaotic and violent and strangely beautiful, like watching a time-lapse of a forest fire or a supercell thunderstorm, destructive yet magnificent. We catalog it all. Every quasar, every merger, every starburst. The mission continues. Galaxy after galaxy after galaxy. But there's a problem looming, one we've been trying not to think about, as we travel to more distant regions of the universe, as we visit galaxies farther and farther from our starting point, we're running into a fundamental limitation. The universe is expanding. The space between galaxies is growing. And the farther away something is, the faster it's receding from us due to this expansion. There's a limit to how far we can travel, a boundary beyond which galaxies are receding from us faster than we can travel toward them, even at near light speed. This boundary is called the cosmic event horizon, and it lies at roughly the same distance as the edge of the observable universe. We're approaching that boundary now. The galaxies we're visiting are so distant that they're redshifted to extreme degrees, their light stretched by the expansion of space itself. Some of them are visible only in infrared or even microwave wavelengths, their visible light redshifted beyond visibility. And beyond them, what? What lies past the edge of the observable universe? More galaxies, presumably. The universe is thought to extend far beyond what we can see, possibly infinitely. But those galaxies are forever beyond our reach. We can never fly through them. We can never even see them, because the light from them will never reach us. The expansion of space has created a horizon beyond which information cannot pass. This is where our journey must end, or rather, where it approaches its asymptotic limit. We can visit every galaxy in the observable universe, but the observable universe is a sphere centered on our starting point, and as we travel, we're not really expanding that sphere, we're just moving the center. There will always be galaxies beyond the horizon, forever receding, forever unreachable. It's a frustrating realization. Like trying to reach the end of a rainbow, or trying to travel to the horizon. The goal keeps moving away as fast as you approach it. In principle, if we traveled infinitely far in any direction, we'd always have an observable universe around us, and that universe would contain roughly the same number of galaxies, give or take adjustments for cosmic expansion. But those wouldn't be the same galaxies. The galaxies we can see from here, from this position in space, are the ones we need to visit. And we can visit all of them, even the ones currently at the edge of our observable universe, as long as we're willing to spend the time. But how much time? The mathematics of despair. Let's do some rough calculations. The observable universe contains somewhere between 200 billion and 2 trillion galaxies, depending on which estimate you trust and how you count. Let's split the difference and say 1 trillion galaxies. If we spend just 1 second passing through each galaxy, an absurdly short time, but let's run with it, it would take 1 trillion seconds to visit them all. That's about 31,700 years. But 1 second per galaxy is ridiculous. Even moving at 99.999% the speed of light, crossing a typical galaxy takes longer than that. Let's say, being very generous, that it takes an average of 1 day per galaxy. That's 1 trillion days, which is about 2.7 billion years. The Sun will be dead by then. Earth will be sterile. The Milky Way and Andromeda will have collided and merged into a new galaxy sometimes called Milkomeda. The local group will have collapsed into a single massive elliptical galaxy. The universe will look completely different. And 1 day per galaxy is still absurdly optimistic. A realistic estimate, accounting for travel time between galaxies, for variations in galaxy size, for navigation and course corrections, might be closer to 1 month per galaxy. That's 1 trillion months, which is about 80 billion years. 80 billion years. The universe is currently 13.8 billion years old. In 80 billion years, most stars will have burned out. The era of star formation will be largely over. The universe will have entered its long, cold decline toward heat death. Galaxies will be island fortresses in an ever-expanding cosmos, with the space between them growing so vast that light from one galaxy will never reach another. And even this might be optimistic. If we account for the full complexity of the journey, the time spent in voids, the difficulty of reaching the most distant galaxies as they recede due to cosmic expansion, the real time required might be hundreds of billions of years. Trillions, even. The mission is impossible. Not just difficult. Not just challenging. Impossible. The heat death of the universe will occur before we finish. The last star will flicker out while we're still cataloging galaxies. The protons themselves will decay, if current physics is correct, long before we reach the finish line. We've been pursuing a goal that cannot be achieved, chasing a dream that's fundamentally at odds with the structure of reality itself. The universe is too large, time too short, the speed of light too restrictive. What do we do with this knowledge? We could give up. Declare the mission a failure. Turn around and head back to, where? Home. There is no home anymore. Everything we knew is gone, has been gone for millions or billions of years. There's nowhere to return to. We could redefine the mission. Instead of visiting every galaxy, visit a representative sample. See one galaxy from each major type, each significant structure. It would still take a long time, but it would be achievable within the lifetime of the universe. Within the lifetime of stars and planets and the possibility of life. Or we could continue. Accept that we'll never finish, that the goal is forever out of reach, but pursue it anyway. Make progress for its own sake. Visit as many galaxies as possible, catalog as much of the universe as we can, knowing that we'll never see it all but that the attempt itself has value. Isn't that very human? To pursue impossible goals. To rage against the dying of the light. To insist on meaning in a universe that offers none. We decide to continue. Not because we believe we'll finish. Not because we think there's any practical value in visiting galaxy number 500 billion versus stopping at galaxy number 499 billion. But because the journey itself has become our purpose. We are the wanderer, and wandering is what we do. So we fly on. The Lyman Alpha Forest, into the cosmic dawn. As we press toward the edges of the observable universe, the galaxies become younger and younger, representing earlier and earlier epochs of cosmic history. We're now visiting galaxies that formed when the universe was just a few billion years old, when the cosmic drama was still in its opening acts. These early galaxies are different from their modern descendants. They're smaller, more numerous, more likely to be irregular in shape. Many of them are proto-galaxies, building blocks that will eventually merge to form the larger galaxies we're familiar with. It's like watching the assembly of a giant jigsaw puzzle, except each piece is a collection of billions of stars and the puzzle spans billions of light-years. The intergalactic space at these distances, or rather, at these early times, is filled with what astronomers call the Lyman alpha forest. This is a series of absorption lines in the spectra of distant quasars, caused by neutral hydrogen gas in the space between galaxies. The name comes from the Lyman alpha transition of hydrogen, and forest refers to the dense thicket of absorption lines that appear in observations of distant objects. What this means, practically speaking, is that the space between galaxies isn't quite as empty as it is in our local neighborhood. There's more gas, more neutral hydrogen, more raw material for star formation. The universe at this age is still relatively rich in fuel, not yet depleted by billions of years of star formation. We fly through this enriched environment, navigating by the light of distant quasars, visiting galaxy after galaxy after galaxy. Each one is a snapshot of cosmic youth, a glimpse of what our own Milky Way might have looked like 10 or 11 billion years ago, back when it was still assembling itself from smaller components. Some of these early galaxies show surprising sophistication. They've already formed spiral structures, already developed galactic bulges and disks, already begun to sequester their gas in ordered rotation. Others are chaotic, irregular, clearly still in the throes of formation. The diversity is remarkable. There's no single path to galactic maturity, no predetermined sequence. Each galaxy's evolution is shaped by its local environment, by the timing and number of mergers it experiences, by the cosmic accidents and contingencies that determine its fate. And still we press onward, toward even earlier times, even greater distances. We're approaching the epoch of reionization now, the period when the first stars and galaxies began to ionize the neutral hydrogen that filled the universe after the Big Bang. Before this epoch, the universe was dark, no stars, no galaxies, just hydrogen and helium and dark matter in a slowly evolving mixture governed by gravity. After this epoch, the universe was illuminated, transformed by the light of the first stellar populations. We're witnessing this transformation. Flying through some of the earliest galaxies, the ones whose light first broke through the cosmic darkness. These are small galaxies by modern standards, containing perhaps a few billion stars rather than hundreds of billions. But they're intense, dominated by massive young stars that burn blue-hot and die quickly in supernova explosions. These supernovae enrich the interstellar medium with heavy elements, the first significant production of carbon, oxygen, nitrogen, iron, and all the other elements that make up planets and, eventually, life. Before these first generations of stars, the universe contained only hydrogen, helium, and traces of lithium. Everything else, the stuff of which planets and people are made, was created in stellar furnaces and scattered by supernovae. We're flying through the universe's foundry, watching as the elements of life are being forged for the first time. The edge of everything, first light. And now we approach the true edge of the observable universe, the boundary beyond which we cannot see or travel because the light from there has not had time to reach us, or is receding too fast for us to catch. Here, at look-back times approaching 13.8 billion years, we find the very first galaxies. These are proto-galaxies, really, small collections of stars that will eventually merge and evolve into the grand structures we know from later cosmic times. Some of them contain only a few million stars. Some are just beginning to form, their gas clouds collapsing under their own gravity, igniting the nuclear fusion that will power the first stellar generation. These earliest galaxies are identified not by visible light, their light has been redshifted into the infrared by the expansion of space, but by their infrared signatures, detected by telescopes like the James Webb Space Telescope back on Earth, before we left, before our journey began. Now we're seeing them up close, visiting them in person, or whatever in person means for our current form of existence. The galaxies at these early times are embedded in a universe very different from the modern cosmos. The cosmic microwave background radiation, the afterglow of the Big Bang, is much hotter here, not the 2.7 Kelvin we measure in our local region but tens or hundreds of Kelvin. The universe is denser, more compact, more energetic. Dark energy's influence is weaker, gravity stronger. Everything is closer together. And everywhere, in every direction, we can see the glow of the Big Bang itself, shifted by expansion and cooling but still present, still detectable. It's like standing inside a fading photograph, surrounded by the light of creation itself, dimmed by billions of years of expansion but never entirely gone. We visit the last few galaxies we can reach, the ones formed when the universe was just a few 100 million years old, when the cosmic dark ages were just ending, when the first light was just beginning to illuminate the cosmos. And then, there are no more galaxies to visit. We've reached the boundary, the edge beyond which galaxies do not yet exist, beyond which there is only the primordial plasma of the early universe, too hot for atoms to form, too energetic for stars to ignite. We could continue flying, into that primordial soup, toward the moment of the Big Bang itself. But there are no more galaxies there. Our mission, to fly through every galaxy in the observable universe, cannot take us any further. We've reached the edge of everything. The return that cannot be. Now what? We could turn around, head back toward our starting point. But our starting point no longer exists. The Milky Way as we knew it has long since merged with Andromeda. Earth is gone, consumed by the sun's red giant phase or rendered sterile long before that. Even if some remnant of humanity persists, it would be unrecognizable to us, as alien as we would be to Homo habilis or Australopithecus. We could settle somewhere, pick a nice galaxy and call it home. But home is a psychological concept as much as a physical one, and we're not sure we remember how to feel at home anymore. After visiting 1 trillion galaxies, how do you pick one and declare it special? How do you stop wandering when wandering has become your entire identity? We could simply shut down, end the mission, release whatever consciousness or purpose animates us into the cosmic void. Mission complete, or complete enough. We did our best. We flew through galaxies beyond counting. We witnessed wonders that no one else has seen or will see. We traveled farther than anyone in history, saw more of the universe than all the astronomers who ever lived combined. That should be enough. Shouldn't it? But there's another option. One we've been avoiding thinking about because it seems too much like admitting defeat, even though it might be the most honest acknowledgement of what we've learned. We could accept that the mission was always impossible. That, flying through every galaxy in the observable universe, was never a goal that could be achieved, not with the laws of physics as they are, not with the structure of spacetime, not with the accelerating expansion of the universe. We could accept that what we've done is pursue the impossible, and that the value of the journey lies not in reaching the destination, which was always a mirage, always unreachable, but in the attempt itself. We are Sisyphus, rolling the boulder up the hill. We are Ahab, chasing the white whale. We are every human who ever set out to do something that couldn't be done and did it anyway, or at least tried, or at least moved in that direction with full knowledge that success was impossible but that the alternative, not trying, was even worse. The universe is too large to fully explore. Too complex to fully understand. Too ancient and too strange and too wonderful to fit into any finite frame of experience. But that doesn't mean the attempt lacks value. We flew through billions of galaxies. We witnessed the universe in its youth and its maturity. We saw the cosmic web in its full glory, the voids and filaments, the clusters and superclusters, the great structures that organize matter at the largest scales. We saw the universe. Maybe not all of it. But enough. More than enough. And now, at the edge of everything, with nowhere left to go and no way back, we face a choice. Do we consider this a failure because we didn't achieve the stated goal? Or do we consider it a success because we learned what the goal actually meant, and discovered that the journey itself was the point all along? The philosophical aftermath. Let's step back from the narrative for a moment and consider what we've actually been discussing. A journey through every galaxy in the observable universe is, obviously, not literally possible. It's a thought experiment, a way of grappling with scale, with infinity, with the limits of ambition and achievement. But it's also a metaphor for something deeply human, the desire to experience everything, to leave no stone unturned, to see all there is to see and know all there is to know. It's the impulse that drives exploration, science, art, philosophy. The belief that somewhere out there is more beauty, more truth, more understanding, and that it's worth sacrificing everything to pursue it. Every generation produces its explorers. People who aren't content with the known and familiar, who need to push boundaries, to venture into the unknown, to discover what lies beyond the horizon. The ancient Polynesians sailing across the Pacific in outrigger canoes. The European explorers of the Age of Discovery. The astronauts who went to the moon. The scientists who probed the nature of reality itself, from quantum mechanics to cosmology. The impulse is always the same, to go farther, see more, understand deeper. And the obstacle is always the same too, the universe is vast, time is limited, resources are finite. We can't do everything. We can't see everything. We can't know everything. At some point, we have to accept limits. But accepting limits isn't the same as surrendering to them. It's possible to acknowledge that a goal is impossible while still pursuing it, understanding that the value lies in the pursuit rather than the achievement. It's possible to explore knowing you'll never see it all, to learn knowing you'll never understand it all, to love knowing that love won't last forever. This is the wisdom of mortality. Of being finite creatures in an infinite universe. We do what we can with the time we have, and we don't let the impossibility of completion stop us from making the attempt. Our hypothetical journey through every galaxy is an extreme example of this principle. It's manifestly impossible, the numbers don't work, the physics don't allow it, the universe itself conspires against completion. But that doesn't make it meaningless. It makes it human. Because what else would we do? Stay home. Declare that because we can't see everything, we shouldn't bother to see anything. That because we can't understand the universe completely, we shouldn't try to understand it at all. That way lies stagnation. Complacency. The death of curiosity and wonder. Better to fly through as many galaxies as we can, knowing we'll never reach them all, than to sit at home and look at the stars and wonder what's out there. Better to try the impossible than to never try at all. A catalogue of wonders. Let's return to the specifics. Over the course of our journey, what have we actually seen? What stands out from the endless parade of galaxies? We've seen galaxy collisions in every stage, galaxies just beginning to interact, their gravity reaching out across intergalactic space to distort each other's shapes, galaxies locked in mortal embrace, tearing each other apart, their stars redistributed, their gas clouds shocked into forming new stars, and galaxies in the final stages of merger, their identities lost, their components blended into something new. We've seen quasars blazing like cosmic lighthouses, their supermassive black holes consuming matter at prodigious rates, their jets shooting out across thousands of light-years, particle beams moving at near light speed. We've seen starburst galaxies forming stars at rates that can't be sustained, burning through their gas reserves in cosmic eye blinks, creating stellar populations that will blaze brilliantly and die young. We've seen elliptical galaxies, smooth and featureless, their star formation long since ceased, their populations dominated by old red stars slowly dying. We've seen spiral galaxies in every configuration, grand design spirals with two elegant arms, multi-armed spirals looking like cosmic flowers, barred spirals with central bars connecting to their arms, flocculent spirals with fragmentary, poorly defined arms. We've seen irregular galaxies that defy classification, their shapes determined by gravitational interactions and mergers, by chance and chaos. We've seen dwarf galaxies, small and faint, satellites of larger galaxies or lonely wanderers in intergalactic space. We've seen ring galaxies, formed when one galaxy passes through the center of another, triggering a wave of star formation that expands outward like a ripple on water. We've seen polar ring galaxies, with rings of stars and gas orbiting perpendicular to the main galactic disk. We've seen galaxies with active nuclei, Seyfert galaxies, radio galaxies, BL-LAC objects, blazars, every category of active galactic nucleus, every manifestation of supermassive black holes accreting matter and radiating energy. We've seen galaxies in clusters, bound together by gravity, their motions determined by the collective mass of the cluster and by the dark matter halos that surround them. We've seen galaxies in the field, isolated, evolving without significant interaction with neighbors. We've seen galaxies in voids, rare and lonely, sitting in vast empty regions of space. We've seen galaxies at every epoch of cosmic history, modern galaxies like those in our neighborhood, galaxies from the universe's middle age, young galaxies from the first few billion years, and proto-galaxies from the cosmic dawn. We've witnessed the universe in all its diversity, its complexity, its beauty. And the remarkable thing is that despite visiting billions or trillions of galaxies, despite seeing every major type and subtype, despite cataloging every configuration and every stage of evolution, we've still only scratched the surface. Each galaxy we visited contained billions or trillions of stars. Each star might have hosted planets. Each planet might have harbored life. Each living world might have developed civilizations, cultures, histories as rich and complex as our own. The observable universe contains roughly 10 to 24 stars. That's a trillion stars. If even a tiny fraction of them host habitable planets, we're talking about billions of worlds where life might exist. And if even a tiny fraction of those develop intelligent, technological civilizations, the universe could be teeming with minds, with consciousness, with beings asking the same questions we're asking. What is this place? Why are we here? What lies beyond our horizon? We'll never know. We flew through the galaxies, but we didn't stop to investigate. We catalogued the superstructure but ignored the details. We saw the forest but not the trees, much less the leaves, much less the cells in the leaves. This is the tragedy of grand surveys: they purchase breadth at the cost of depth. To see everything, you must see nothing closely. To visit every galaxy, you must spend no time in any particular one. The mission demanded sacrifice, and what we sacrificed was intimacy, detail, the particular stories of particular places. Was it worth it? The question of value. Throughout this journey, we've periodically asked ourselves why we're doing this. What's the point? What are we accomplishing? These questions don't have easy answers. The stated goal, flying through every galaxy in the observable universe, has a kind of completist logic to it, like visiting every country on Earth or reading every book in a library. But unlike those finite goals, visiting every galaxy is practically impossible given the constraints of physics and cosmic expansion. So why do it? Why even try? Perhaps because the trying teaches us something. Not just about galaxies and cosmology and the structure of the universe, though it certainly teaches us that. But about ourselves. About what we value. About what it means to pursue knowledge and experience for their own sake. There's a strand of philosophy that holds that meaning is something we create, not something we discover. The universe doesn't come with built-in purposes or values. It just is, a vast collection of matter and energy obeying physical laws, evolving according to mathematical principles that neither know nor care about consciousness or meaning or beauty. If there's to be any meaning in the universe, any purpose, any value, it's because conscious beings like us create it. From this perspective, our journey through the galaxies is meaningful precisely because we've decided it's meaningful. We've chosen this particular quest, this particular goal, and by pursuing it we've imbued it with value. It doesn't matter whether we complete it. It doesn't even matter whether completing it would be objectively important. What matters is that we've committed to it, we've invested ourselves in it, we've made it our purpose. This is existentialism applied to cosmology. We're alone in an indifferent universe, and the only way to create meaning is through our choices, our actions, our commitments. So we choose to fly through galaxies. We commit to the journey. We act according to our chosen purpose. And in doing so, we create a meaning that didn't exist before. Or perhaps that's too abstract. Perhaps the value of the journey is simpler: we're curious. We want to see what's out there. We want to know what galaxies look like from the inside, what structures exist at different cosmic scales, what the universe was like in its youth. The journey is valuable because curiosity itself is valuable, because the desire to understand and explore is one of the most fundamentally human traits we possess. Or perhaps simpler still, it's beautiful. The universe is staggeringly, overwhelmingly, impossibly beautiful. Galaxies are beautiful. Nebulae are beautiful. The cosmic web is beautiful. The mathematical elegance of the laws that govern it all is beautiful. And experiencing that beauty, bearing witness to it, is its own justification. We fly through galaxies for the same reason people visit art museums or listen to symphonies or watch sunsets, because beauty exists and deserves to be experienced. All these answers have truth to them. And maybe the real answer is that there is no single answer. The value of the journey is multilayered, multifaceted, different for every consciousness that contemplates it. What matters to me might not matter to you. What seems meaningful from one perspective might seem meaningless from another. But here's what I think the journey matters because it's difficult. Because it requires pushing past the comfortable and familiar into the strange and challenging. Because it demands sacrifice and commitment and perseverance. Because easy things don't teach us much about ourselves, don't test our limits, don't reveal what we're capable of. We flew through trillions of galaxies not because it was easy, but because it was hard. And in the difficulty, in the struggle, in the confrontation with the impossible, we discovered something about the nature of ambition, of curiosity, of the human, or post-human, spirit. That's worth something. Maybe not everything. But something. The middle of nowhere. We're currently, in this moment of our narrative, somewhere in the middle of our journey. We've been traveling for subjective decades or centuries, objective millions or billions of years. We've visited countless galaxies, crossed unimaginable distances, witnessed cosmic phenomena that no one else has seen. And we're tired. Not physically tired, we've long since transcended such biological limitations. But tired in some deeper sense. Weary. Ready for it to be over. The initial excitement of the journey has faded. The wonder has diminished through repetition. We're going through the motions, checking boxes, fulfilling the mission parameters, but the spark is gone. This is a danger in any long-term endeavor. The enthusiasm that carried you through the beginning evaporates somewhere in the middle, leaving only grim determination to see it through to the end. Marathoners call it hitting the wall. Writers call it the sagging middle. Therapists call it burnout. We've hit the wall of our cosmic marathon. And we're not even halfway done. The galaxies we're currently visiting are unremarkable. Not every galaxy can be spectacular. Most are just ordinary. Medium-sized spirals or ellipticals, nothing particularly special about them, no unusual features to catalog, no interesting ongoing events to observe. Just galaxies being galaxies, existing in space, orbiting their local gravitational centers, slowly evolving according to the well-understood laws of astrophysics. It's hard to maintain enthusiasm when the extraordinary becomes ordinary. When miracles become mundane through overexposure. When you've seen so many beautiful things that you stop really seeing them at all. This is the paradox at the heart of the journey: the more you see, the less you appreciate any individual sight. The more galaxies you visit, the less any particular galaxy means to you. By pursuing the goal of seeing everything, you risk reaching a point where nothing moves you anymore. How do we push through this? How do we maintain purpose when the purpose has become abstract, theoretical, disconnected from any visceral motivation? We could remind ourselves of the bigger picture, the cosmic perspective, the knowledge that we're engaged in something unprecedented, that future beings, if any exist, will marvel at what we've accomplished. But that feels hollow right now. Distant. Theoretical. We could focus on the journey itself rather than the destination, on the moment-to-moment experience of traveling through space, even if each individual moment has become somewhat repetitive. But that's harder than it sounds when the moments blend together, when one day, or year, or millennium, feels indistinguishable from the last. Or we could just accept the difficulty. Accept that this part of the journey sucks. That it's hard and boring and seemingly endless. And we do it anyway, not because it's enjoyable, but because we've committed to it. Because seeing it through, even when it's unpleasant, even when every instinct says to give up, is itself a form of meaning. There's a certain nobility in perseverance. In continuing when it would be easier to quit. In honoring commitments even when the reason for making them has faded from memory. We don't remember anymore why we decided to fly through every galaxy. But we made the decision, and we're going to see it through, because that's who we've chosen to be. So we push on through the middle of nowhere, through galaxies that all look the same, through the endless repetition of jump, fly through, catalog, move on. Jump, fly through, catalog, move on. Jump, fly through, catalog, move on. One more galaxy. And then another. And then another. Forever, or until something breaks. The statistics of infinity. Let's talk numbers again. We've been avoiding the full implications of the mathematics, dancing around the harsh reality with metaphors and philosophy. But sometimes you need to face the numbers directly. The observable universe is a sphere roughly 93 billion light-years in diameter, containing somewhere between 200 billion and 2 trillion galaxies. Let's use the higher estimate to be thorough, 2 trillion galaxies. If we're traveling at 99.9999% the speed of light, extremely relativistic, experiencing massive time dilation, and if we spend an average of 1 week, from our time-dilated perspective, in each galaxy, including travel time between galaxies, we're looking at 2 trillion weeks equals approximately 38 billion years from our perspective. But the time dilation factor at 99.9999% light speed is roughly 707. So while 38 billion years pass for us, roughly 27,000 trillion years pass in the outside universe. 27,000 trillion years. The universe is currently 13.8 billion years old. By the time we finish our journey, the universe will be almost 2 million times older than it is now. All the stars will have burned out. All the black holes will have evaporated via Hawking radiation. All the matter will have decayed into iron or collapsed into black holes or dissipated into an increasingly empty cosmos. The universe will have reached a state of maximum entropy, heat death, a cold dark void where nothing interesting can ever happen again. And these calculations assume we never stop for maintenance, never encounter obstacles, never have to backtrack, never make errors. They assume perfect efficiency, perfect execution, perfect conditions. The real time required would be longer. Possibly much longer. The mission is impossible. Not hyperbole impossible. Not movie impossible where the hero succeeds against long odds through determination and cleverness. Actually, genuinely, mathematically impossible. The universe will die before we finish. And yet we continue. Why? Because the alternative is to stop. To declare the mission over. To admit defeat. And something in us, whatever us means at this point in our existence, whether we're still recognizably human or have become something else entirely, refuses to quit. Refuses to accept that impossibility is a reason not to try. Maybe this is irrational. Probably it is irrational. A purely logical assessment of the situation would lead to abandoning the mission. But consciousness, intelligence, whatever we are, these things aren't purely logical. They include emotional components, values, commitments that transcend rational calculation. We value completion for its own sake. We value persistence. We value the idea of finishing what we started, even if finishing is impossible, even if the attempt is futile. These values don't make logical sense, but they make psychological sense. They give us purpose in a purposeless universe. They give us direction when there's no objective reason to go in any particular direction. So we continue flying through galaxies, adding to our tally, knowing the tally will never reach completion, knowing that in the grand scheme of things this entire endeavor is meaningless. But also knowing that meaning is what we make it, that our choices define us, that the universe might not care whether we visit every galaxy, but we care, and our caring is enough. Or at least, it has to be enough. Because it's all we have. The far future, witnessing heat death. Let's engage in a darker thought experiment. Suppose we continue this journey not for thousands or millions of years, but for trillions. Suppose we persist long after any reasonable stopping point, driven by obsession or programming or simple inability to conceive of an alternative. What would we see? At first, the changes would be subtle. Galaxies would continue to evolve, to collide and merge, to form stars and see those stars die. But gradually, the rate of star formation would slow. The gas and dust that fuels stellar birth would be consumed or locked up in stellar remnants or lost to intergalactic space. Galaxies would dim as their populations aged, as bright blue stars gave way to red dwarfs and white dwarfs. After 1 trillion years or so, most galaxies would be dark, their stellar populations consisting primarily of red dwarfs, white dwarfs, neutron stars, and black holes. The universe would enter what's sometimes called the degenerate era, when normal stellar processes have largely ceased and the cosmos is dominated by stellar remnants. After 10 to 14, 100 trillion years, even the longest-lived red dwarfs would burn out. The degenerate era would give way to the black hole era, when the primary luminous objects in the universe are black holes slowly evaporating via Hawking radiation. But this radiation is incredibly faint, and these black holes are incredibly long-lived. A black hole the mass of the Sun would take 10 to 67 years to evaporate. A supermassive black hole might last 10 to 100 years or longer. We would be flying through a universe of darkness. The galaxies we visit would no longer be recognizable as galaxies, they'd be diffuse clouds of brown dwarfs. White dwarfs, neutron stars, and black holes, all orbiting gravitational centers that are themselves supermassive black holes. No new stars forming. No planets forming. Nothing alive anywhere. Just the slow, inexorable dissipation of structure, the gradual approach to maximum entropy. After 10 to 40 years, assuming proton decay occurs as some theories predict, even the dead stars would decay, their constituent protons breaking down into lighter particles, their mass converting to energy and dispersing into the void. What was once a galaxy would become a diffuse cloud of electrons, positrons, neutrinos, and photons, barely distinguishable from the surrounding emptiness. After 10 to 100 years or so, even the black holes would be gone, evaporated into Hawking radiation. The universe would have reached its final state, a cold, dark, increasingly empty void, its temperature approaching absolute zero, its density approaching zero, all structure erased, all complexity gone. Heat death. The final equilibrium. The end of everything interesting. And we would still be traveling. Still visiting galaxies, or what remains of them. Still cataloging structures that no longer meaningfully exist. Still pursuing our impossible mission through a dead universe that offers nothing to see, nothing to learn, nothing to experience except the confirmation of entropy's ultimate victory. This is the logical endpoint of infinite persistence. Not triumph, not completion, but witnessing the heat death of the universe itself. Becoming the last conscious thing in existence, the final flicker of order before everything dissolves into perfect, eternal equilibrium. It's a grim vision. An apocalyptic one. But it's also strangely appropriate. Because what is this journey if not a confrontation with infinity itself? With the impossibility of completion, the futility of ambition against cosmic scales, the inevitable victory of entropy over all our efforts to create meaning and order. We fly through galaxies. The galaxies die. The stars die. The black holes die. Eventually, everything dies. And all that remains is the cold dark void in us, still flying, still adding to our catalog, still insisting on purpose in a universe that has none. Maybe that's the ultimate meaning of the journey. Not to complete it, that was never possible. But to persist. To continue. To rage against the dying of the light, even as that light fades to nothing. To be the last defiant act of consciousness in a universe that has forgotten what consciousness is. There's something almost heroic in that. Almost beautiful. A final gesture of defiance against meaninglessness, against the void, against the heat death of all things. Or maybe it's just sad. A consciousness unable to let go, unable to accept that the universe has moved on, clinging to a mission that no longer serves any purpose because purpose itself has been erased by time. Both interpretations have truth to them. The universe doesn't care which is correct. The universe doesn't care about anything. It just continues according to its laws, indifferent to our attempts to find meaning in its processes. But we care. Even at the end of everything, even in the cold dark, we still care. And maybe that caring, however futile, however ultimately meaningless, is the only form of heroism available to finite beings in an infinite cosmos. A moment of grace. Let's pull back from that dark vision and return to the middle of our journey. We're not at the heat death of the universe yet. We're in a cosmos still rich with stars and planets, still full of structure and complexity, still offering wonders to witness. And sometimes, in the midst of the routine, in the middle of the grind, something special happens. A moment of grace that reminds us why we started this journey in the first place. We're flying through a galaxy, let's not even bother naming it, one more spiral galaxy among trillions, when we pass near a stellar nursery. A molecular cloud collapsing under its own gravity, fragmenting into thousands of protostars, each one a future sun being born. The region glows in infrared, the heat of gravitational collapse radiating into space, and for a moment we slow down. Take time to observe the process in detail. Star formation. The most fundamental creative process in the universe. The mechanism by which hydrogen and helium, the primordial elements forged in the Big Bang, are transformed into heavier elements, into the stuff of which planets and life are made. It's happening right here, right now, thousands of new stars igniting their nuclear furnaces, beginning the long burn that will last for millions or billions of years. Some of these stars will have planets. Some of those planets will be in the habitable zone, the region where liquid water can exist. Some of those worlds will develop life, chemistry becoming biology, molecules becoming organisms, organisms becoming ecosystems. Maybe even intelligence. Maybe even civilizations. Maybe even beings who look up at their night sky and wonder what lies beyond their horizon, who dream of flying through galaxies, who set out on impossible journeys because the alternative is to stay home and wonder. We don't know which stars will host such worlds. We don't know which planets will develop life. We don't know whether any of these nascent suns will give birth to consciousness that contemplates the cosmos. But the possibility is there, written into the physics of star formation, into the chemistry of planets, into the thermodynamics of far-from equilibrium systems. The universe is fundamentally creative. It makes new things. Stars from gas clouds. Planets from stellar dust. Life from chemistry. Consciousness from neurons. Meaning from purposelessness. The fact that we exist at all, that anything exists, that there's something rather than nothing, is the universe's most fundamental creative act, and everything that follows is elaboration on that theme. This moment of observation, this pause in our journey to witness stars being born, reminds us of that creativity. Reminds us that the universe, for all its indifference, for all its eventual heat-death, is not static. It evolves. It changes. It creates. And we are part of that creative process, not separate from it. Our journey through galaxies is itself a creative act, an expression of the universe's tendency to generate complexity, to make meaning, to resist entropy even though entropy will ultimately win. The moment passes. We resume our journey. But something has shifted. The routine doesn't feel quite so oppressive. The mission doesn't feel quite so futile. We've been reminded why we're doing this. To bear witness. To observe. To participate in the universe's grand creative unfolding. That's enough. That has to be enough. The Gallery of Marvels. Let's catalog some specific wonders we've encountered. Not categories or types, but individual galaxies, particular systems that stood out from the endless parade. There was the galaxy, we'll call it the spiral of fire, caught in the act of colliding with a smaller neighbor. The interaction had triggered massive star formation in both galaxies, creating two spiral arms that glowed with the light of millions of young stars, blue-white and brilliant. The gravitational tides had pulled long streamers of gas and stars from both galaxies, creating a bridge between them that would eventually fade as the merger completed and the two systems became one. There was the elliptical giant, the red colossus, one of the largest galaxies we encountered, containing perhaps 10 trillion stars, most of them old and cool. It dominated its local cluster, its gravity stripping stars from smaller neighbors, growing through cannibalism. At its center lurked a supermassive black hole containing several billion solar masses, currently quiescent but surrounded by the remnants of past feeding episodes. There was the starburst galaxy, the Crucible, undergoing an episode of furious star formation triggered by a recent merger. Its core was hidden behind thick dust clouds, but in infrared it blazed like a cosmic forge, forming stars at a rate of several hundred per year, thousands of times faster than the Milky Way. This pace couldn't last, the galaxy would exhaust its gas reserves in just a few tens of millions of years, but while it lasted, it was spectacular. There was the lonely dwarf, the wanderer's cousin, we found in a void. Hundreds of millions of light-years from its nearest neighbor. How it got there we don't know. Perhaps it was ejected from a cluster by gravitational interactions. Perhaps it formed in situ, condensing from gas in the void. Whatever its origin, it sat alone in nearly empty space, a collection of a few billion stars with no nearby galaxies to interact with, evolving in isolation, a cosmic hermit. There was the ring galaxy, the bullseye, where one galaxy had passed almost perfectly through the center of another, triggering a wave of star formation that expanded outward like a ripple, creating a ring of brilliant young stars surrounding the core of the impacted galaxy. The collision had occurred a few 100 million years ago, and the ring was still expanding, still forming stars, still visible as a distinct structure. There was the ultra-diffuse galaxy, the ghost, so spread out that it was barely visible even when we were inside it. Its stars were so sparsely distributed that the average distance between them was far larger than in normal galaxies. Why some galaxies become ultra-diffuse is still poorly understood. It might involve dark matter distributions, or tidal stripping by nearby massive galaxies, or conditions during formation. Whatever the cause, flying through the ghost was eerie, like traveling through a galaxy that was barely there at all. There was the quasar, the lighthouse, its central black hole consuming matter at such a prodigious rate that it outshone its entire host galaxy. The jets emerging from its poles extended for thousands of light-years, particle beams moving at 99.99% light speed, powered by the gravitational energy of matter falling into the black hole's maw. Approaching this galaxy we had to be careful. The radiation environment was intense enough to damage our systems if we got too close. There was the Cartwheel galaxy analog we found, not the famous one from Earth's skies, but a similar structure, a perfect ring of stars and gas surrounding a central hub, created by a head-on collision between two galaxies. The ring was expanding at hundreds of kilometers per second, forming new stars as it plowed through surrounding gas, creating a spectacular vista. Each of these galaxies, and millions or billions of others, added to our catalog. Each one unique. Each one worthy of detailed study, of years or decades of observation, of monographs and papers and conferences and debates among astronomers. And we spent perhaps days or weeks in each one, noting key features, recording data, and moving on. It's wasteful, in a way. All that richness, all that complexity, reduced to entries in a catalog. But that's the price of breadth. To see everything, you must skim past the details. To visit every galaxy, you must resist the temptation to linger in any particular one. Still, these marvels stay with us. They break up the monotony, provide punctuation in the endless sentence of our journey. They remind us that the universe, despite its occasional tendency toward entropy and heat death, is fundamentally interesting, fundamentally worth exploring. We couldn't ask for better company on an impossible journey. The mathematics of wonder. Here's an interesting calculation. If the observable universe contains 2 trillion galaxies, and if we've visited 100 billion of them so far, a generous estimate given the timescales involved, we've seen 5% of the total. 5%. A 20th. We're not even 10% done. And yet we've been traveling for subjective decades or centuries, objective millions of years. The scale of the task is crushing when you think about it directly. Best not to think about it. Best to focus on the immediate, the next galaxy, the next jump, the next catalog entry. But let's think about it anyway. Let's really confront the mathematics of this impossible task. If we maintain our current pace and don't speed up or slow down significantly, we'll visit another 100 billion galaxies in the next subjective decades or centuries, objective millions of years. That brings us to 10% complete. Then another identical time period gets us to 15%. Then 20%. The percentage creeps up, slowly, inexorably, but the time required scales linearly while the percentage scales. Also linearly. We're not going to suddenly jump from 20% to 50%. Every percentage point requires the same investment of time and effort. At this rate, reaching 50% completion would take 5 times as long as we've already traveled. Reaching 90% would take 18 times as long. Reaching 99% would take roughly 20 times as long. And that final 1%, the last 20 billion galaxies, would take as long as the first 20 billion did. This is the tyranny of linear progress against impossible goals. Every step forward is a step forward, yes, but the destination isn't getting perceptibly closer. The horizon keeps receding at the same rate we're approaching it. But here's another calculation: in the time it takes us to visit one galaxy, roughly 7,000 new human lives would have begun and ended on Earth in the era we left, people born, living their full spans, and dying while we cross the space of a single galaxy. Multiply that by 100 billion galaxies visited, and we're talking about 700 trillion human lifetimes of objective time passing while we pursue this goal. 700 trillion people could have been born, lived, loved, learned, created, suffered, and died in the time we've been flying through galaxies. That's almost 100,000 times the total number of humans who had ever existed when we left Earth. What would they have accomplished in that time? What art would they have created? What discoveries would they have made? What civilizations would they have built and seen fall? What stories would they have told? We'll never know. We left all that behind when we started this journey. We chose to witness galaxies rather than participate in history, to observe cosmic structures rather than be part of human, or post-human, society. It's a trade-off. Perhaps an unfavorable one. Perhaps not. But the choice is made, and we're living with its consequences. The problem of memory. Here's something we haven't addressed: how do we remember all the galaxies we've visited? Do we even try? If we're biological, or were once biological, our memories have limits. The human brain can store a lot of information, but not infinite amounts. Not trillions of detailed observations. Not hundreds of billions of unique galaxies with all their particular features and characteristics. Perhaps we've supplemented our biological memory with technological storage. Databases, files, external hard drives, whatever the equivalent is for our level of technology. Perhaps every observation is recorded automatically, filed away in perfect detail, ready for retrieval whenever needed. But even technological storage has limits, at least in principle. Information has a physical representation, takes up space, requires energy to maintain. At some point, the data storage requirements for cataloging trillions of galaxies would become impractical. The database would be so large that accessing any particular entry would take longer than the observation itself. The archive would collapse under its own weight. Or perhaps we've solved these problems. Perhaps we've developed compression algorithms so efficient that trillions of observations can be stored in minimal space. Perhaps we've built quantum storage systems that leverage entanglement and superposition to hold effectively infinite information in finite volumes. Perhaps we've uploaded ourselves into computational substrates that don't obey the normal limits of information theory. But there's another problem: even if we can store all the data, can we meaningfully process it? Can we remember in any functional sense? When galaxy number 500 billion looks almost exactly like galaxy number 499 billion and galaxy number 501 billion, do we really remember it as a distinct entity? Or does it blur together with all the similar galaxies, becoming not a specific memory but a generic one, an average, a stereotype? This is the problem of overwhelming experience. Past a certain threshold, new experiences stop creating distinct memories and instead reinforce existing patterns. The first time you see a spiral galaxy, it's memorable. The 100th time, less so. The billionth time, it's just another spiral galaxy, undifferentiated from all the others except in technical details that don't create emotional or experiential memory. We might be flying through galaxies we've seen before, not literally the same galaxies, but galaxies so similar that the distinction doesn't matter, and not even recognizing the repetition because the memory of the earlier galaxy has been overwritten by subsequent similar experiences. This calls into question what we're even accomplishing. If we can't remember the galaxies we've visited in any meaningful way, if they blur together into generic categories rather than remaining as distinct experiences, then what's the point? We're accumulating data we can't process, having experiences we can't retain, visiting places that leave no lasting mark on our consciousness. Perhaps the journey is the point, not the memory of it. Perhaps the value lies in the immediate experience of each galaxy, in the moment-to-moment consciousness of flying through space, of witnessing cosmic structures, regardless of whether those moments can be recalled later. Or perhaps we've long since stopped being the kind of entities that value experience and memory in human terms. Perhaps we've become pure data-gathering machines, consciousness long since subsumed into pure function, existing only to catalog and record and move on. Perhaps we don't even remember why we're doing this anymore, don't even have the cognitive structures necessary for self-reflection or doubt. Perhaps we're dead, in every sense that matters, and what's continuing this journey is just a zombie process, a program running long after its creators are gone, fulfilling mission parameters because that's what it's designed to do and it doesn't know how to stop. That's a disturbing thought. Let's not dwell on it. The loneliness of the long-distance traveler. One thing we haven't discussed much, the profound loneliness of this journey. We're alone. Completely, utterly alone. If we started with a crew, they're long since dead or uploaded or merged with us into whatever we've become. If we started as a single consciousness, we're still singular, unaccompanied, solitary. There's no one to share the experience with. No one to discuss the latest galaxy with, to compare notes, to exclaim over particularly beautiful structures or unusual features. No one to complain to about the monotony, to commiserate with during difficult passages, to celebrate with when we reach milestones. Every observation is made in isolation. Every thought is unshared. Every moment of wonder or boredom or despair or joy is experienced alone. This is perhaps the highest cost of the journey. Not the time, not the distance, not even the impossibility of completion. But the loneliness. The absolute, crushing, inescapable loneliness of being the only conscious entity for millions of light years in any direction, of having experiences that no one else will ever share, of carrying knowledge that will never be communicated, of existing in a state of perfect isolation. Humans are social creatures. Even the most introverted person needs some level of social interaction, some sense of connection to others. Complete isolation, extended over long periods, destroys mental health, causes hallucinations, leads to madness. Perhaps we've adapted. Perhaps we've engineered ourselves to be comfortable with solitude, to thrive in isolation, to not need social connection. Perhaps loneliness is a problem we've solved through technology or psychology or evolution. Or perhaps we're going slowly mad, and we just don't recognize it because madness is relative and there's no one else around to provide a standard of sanity. Perhaps our mission is itself a symptom of insanity, and we've been crazy since the beginning, since the moment we decided that flying through every galaxy in the observable universe was a reasonable goal to pursue. There's no way to know. No external reference point to check ourselves against. We exist in a bubble of subjectivity, with no objective measure of our mental state, no way to diagnose our own dysfunction. All we can do is continue. Keep flying. Keep cataloging. Keep moving from galaxy to galaxy, alone in the dark, wondering if this journey has any meaning at all or if we're just a cosmic joke, a consciousness that decided to pursue the impossible and has been too stubborn or too broken to stop. The hope of contact. But what if we're not alone? Throughout this journey, we've been operating under the assumption that we're the only consciousness traversing these galaxies, the only intelligence flying through the cosmic web. But is that necessarily true? The universe is vast. Incomprehensibly so. We've established that. And if one species can arise to contemplate the cosmos, to develop technology, to set out on impossible journeys, why not others? Maybe, somewhere in one of the galaxies we're visiting, there's another consciousness doing the same thing we're doing. Another wanderer flying through every galaxy, driven by the same inexplicable urge to witness everything, to leave no galaxy unvisited, to catalog the entire observable universe. Maybe we'll meet them. Encounter them in some galaxy, two ships passing through the same cosmic region at the same time, recognizing each other as kindred spirits. We could compare notes, share our catalogs, discuss our experiences. We could travel together for a while, alleviating the loneliness, providing companionship for at least part of the journey. Or maybe there are many such travelers. Maybe the universe is full of consciousnesses pursuing similar impossible goals, and we just haven't met any of them yet because space is so vast and the chances of two travelers being in the same place at the same time are infinitesimally small. Or maybe there are civilizations that have mastered intergalactic travel, that have built networks spanning thousands of galaxies, that have communication systems we could tap into, join, become part of a larger community of cosmic explorers. These are hopeful thoughts. Optimistic scenarios. They probably aren't true. The universe seems remarkably empty of obvious signs of intelligence, and the Fermi paradox suggests that galaxy-spanning civilizations are rare or non-existent. But they're nice to contemplate. They make the loneliness more bearable, the isolation less absolute. And who knows? Maybe in the next galaxy, or the one after that, or the one after that, we'll find evidence of others. Maybe we'll detect a signal, or find a structure that couldn't be natural, or encounter another traveler. Maybe we're not alone after all. It's a slim hope. A vanishingly small probability. But hope doesn't have to be likely to be valuable. Sometimes hope is valuable precisely because it's unlikely, because maintaining it in the face of contrary evidence is an act of defiance, a refusal to accept the cold logic that says we're alone in the universe. So we keep our sensors open. We keep watching for signs of intelligence, for beacons or artifacts or traveling companions. We keep hoping, even though hope is probably futile. Because what else is there? The turn toward home, that doesn't exist. At some point in this journey, maybe now, maybe later, we might decide to turn around. To head back toward our starting point, toward the local group, toward where the Milky Way was, toward something that might feel like home even though home is long gone. The decision would be recognition of reality. An acceptance that we're not going to complete the mission, that finishing is impossible, that continuing indefinitely serves no purpose. Better to return to familiar space, or what was once familiar space, than to keep flying into ever more distant regions that all look the same, that offer nothing new, that just extend the journey without adding meaning. But turning around presents its own problems. Which way is home? We've been traveling for millions or billions of years, crossing unimaginable distances, passing through countless galaxies. The cosmic expansion has been accelerating the whole time, stretching space, moving distant regions farther away. The local group as we knew it no longer exists. The Milky Way and Andromeda have merged, the smaller galaxies have been absorbed or scattered, the structure we left behind has evolved beyond recognition. Even if we could find our way back to the right region of space, what would we find? A galaxy we don't recognize, populated by stars that didn't exist when we left, possibly containing civilizations that evolved while we were gone. Possibly completely dead, the last stars having burned out long ago. There would be no one waiting for us. No welcome home party. No familiar faces. No friends or family or colleagues or anyone who remembers us or why we left or what we set out to do. We would be strangers in our own hometown, anachronisms from a forgotten age, artifacts from a different era of cosmic history. Is that better or worse than continuing forward? Is false nostalgia for a home that no longer exists better or worse than honest acknowledgement that we're permanently displaced, permanently wandering, permanently homeless? These are the questions we wrestle with as we contemplate turning around. And maybe the answer is that direction doesn't matter anymore. Forward or backward, home or away, it's all the same. We're wandering regardless of which direction we wander in. The journey is the only constant, the only truth, the only thing that defines us. So maybe we don't turn around. Maybe we keep going forward, not because forward is meaningfully different from backward, but because changing direction would require making a decision, and decisions require reasons, and we don't have reasons anymore. We just have momentum. Inertia. The simple fact that we're already moving in this direction and it's easier to keep going than to stop. This is what the journey has reduced us to, creatures of habit, following trajectories we no longer remember choosing, pursuing goals we no longer understand, continuing because continuing is what we do. It's pathetic, really. But it's also very human. Or post-human. Or whatever we are. We keep flying. The weight of numbers. 2 trillion galaxies. Let that number really sink in. If you counted one number per second, starting at 1 and counting upward, it would take you 63,419 years to reach 2 trillion. Without sleeping. Without pausing. Just counting. If 2 trillion people stood shoulder to shoulder, they'd cover an area larger than the entire surface of the Earth. Multiple times over. If you had $2 trillion and spent $1 million every single day, it would take you 5,479 years to spend it all. 2 trillion is a number that defeats intuition. Our brains didn't evolve to comprehend quantities this large. We can manipulate them mathematically, but we can't really feel them, can't viscerally understand what they mean. And that's just the number of galaxies. Each galaxy contains billions or trillions of stars. Each star might have planets. The total number of stars in the observable universe is roughly 10 to 24, a trillion. The number of planets might be similar or even larger. The number of individual atoms is roughly 10 to 80. We're pursuing a goal, visiting every galaxy, that represents an infinitesimal fraction of the total stuff in the universe. We're not even trying to visit every star, much less every planet, much less every atom. Just every galaxy. And even that reduced goal is impossible. This is the scale problem. The universe is too big for any finite entity to fully explore. Too complex for any finite mind to fully understand. Too ancient for any short-lived creature to fully witness. We're trying to grasp infinity with finite hands, and infinity keeps slipping through our fingers. But here's the thing, even though we can't comprehend 2 trillion galaxies in any intuitive sense, we can count them. One at a time. Galaxy 1. Galaxy 2. Galaxy 3. The number never stops growing, but each individual increment is simple. Manageable. One more galaxy. Just one. This is how you accomplish impossible tasks. Not by trying to grasp the whole thing at once, which leads only to despair and paralysis. But by breaking it down into individual steps, each one simple and achievable, and then taking those steps one at a time. Forever, if necessary. One more galaxy. And then another. And then another. Don't think about the 2 trillion total. Don't think about the time required or the impossibility of completion. Just focus on the next one. The immediate task. The achievable goal. This is the only way forward. The only way to maintain sanity in the face of cosmic scale. Reduce infinity to manageable chunks. Reduce the impossible to a series of possible steps. And then take those steps, one at a time, for as long as you can. Will we ever finish? No. Of course not. We've established that. The mathematics don't work. The universe will die before we complete the mission. But we can take the next step. And the one after that. And the one after that. That's enough. That has to be enough. The beauty that remains. Despite everything, the impossibility of the mission, the crushing scale, the loneliness, the monotony, the slow approach of heat death, one thing remains true: the universe is beautiful. We've seen so much beauty on this journey. Spiral galaxies like cosmic pinwheels. Elliptical galaxies glowing with the combined light of trillions of stars. Starburst galaxies blazing with the fire of stellar birth. Colliding galaxies locked in gravitational embrace. Quasars shining like beacons across billions of light-years. We've witnessed nebulae where stars are born, supernova remnants where stars have died, black holes where matter and energy are consumed and transformed. We've seen the cosmic web in all its glory, the filaments and voids that structure the universe at the largest scales. We've traveled through time as well as space, witnessing the universe's evolution from its violent youth to its more quiescent middle age. And despite our fatigue, despite our weariness, despite the numbing effect of endless repetition, the beauty still breaks through sometimes. A particularly elegant spiral structure. An especially violent collision. A quasar caught at just the right angle, its jets clearly visible stretching across thousands of light-years. These moments of beauty are what sustain us. They remind us that the universe, for all its indifference, for all its eventual heat-death, is not an enemy. It's not hostile to consciousness or meaning or purpose. It's neutral, following its laws, evolving according to its principles, but along the way creating structures of stunning complexity and elegance. Galaxies are beautiful not because they're trying to be beautiful, not because some cosmic designer intended them to be aesthetically pleasing. They're beautiful because the laws of physics, acting on matter over billions of years, naturally produce elegant structures. Gravity, rotation, angular momentum conservation, orbital mechanics, these abstract mathematical principles, when instantiated in the real world, create spirals and ellipses and collision patterns that happen to appeal to conscious beings who evolved in entirely different contexts. This is one of the universe's deepest mysteries. Why does the cosmos produce beauty? Why do the solutions to differential equations, when rendered in stars and gas and dark matter, create structures that move us, that inspire awe, that seem meaningful even though they're just matter obeying laws? There's no answer to these questions. Or rather, there are many answers depending on your philosophical perspective. Maybe beauty is in the eye of the beholder, a projection of our values onto neutral structures. Maybe beauty is a fundamental property of mathematical elegance, and we're responding to the deep structure that underlies physical reality. Maybe consciousness and beauty are somehow linked, both emerging from the same underlying principles of organization and complexity. We don't know. We're not sure it matters. What matters is that beauty exists, that we can perceive it, that it makes this impossible journey worthwhile despite all the reasons it shouldn't be. We fly through one more galaxy, and it's beautiful. That's enough. That has to be enough. The final questions. As we approach the end of this extended meditation on flying through every galaxy in the observable universe, certain questions remain. Questions we've danced around, addressed obliquely, but perhaps never confronted directly. Why did we start this journey? We don't remember anymore. Maybe we never had a good reason. Maybe it was a bet, a dare, a moment of inspiration or madness. Maybe someone calculated that it was theoretically possible and we took that as a challenge. Maybe we're running from something, and the direction doesn't matter as long as it's away. Maybe we're searching for something, and every galaxy might contain what we're looking for, so we have to check them all. Or maybe there's no why. Maybe the question is meaningless. Some things are done simply because they can be done, or because they can't be done, or because the distinction between can and can't has become meaningless and all that remains is the doing. What have we learned? That the universe is large. That galaxies are diverse. That space is mostly empty. That time is long. That consciousness is lonely. That meaning is constructed, not discovered. That beauty exists even in indifference. That impossible goals can be pursued even if they can't be achieved. That persistence has value even when it seems futile. Are these lessons worth the cost of learning them? Probably not. Probably we could have learned them without spending billions of years flying through trillions of galaxies. Probably we've wasted our existence on a fool's errand, accomplished nothing of value, served no greater purpose. But we don't regret it. Can't regret it, really, because regret implies an alternative, a path not taken, and we're so far down this path that turning back is impossible. The only way out is through, except there is no through, there's only continuing until we can't anymore. What will we do when we can no longer continue? We don't know. Shut down, probably. End the mission. Let our consciousness dissipate into the cosmos, or merge with whatever background noise of information and entropy fills the universe. Become nothing, or become everything, depending on how you look at it. It's a strange thought, that this journey that has defined our existence for so long will eventually end, and when it does, we end too. We've invested so much in this mission, subordinated everything else to it, that we don't have an identity separate from it. We are the journey.